morning, everybody. It is Monday, Hurricane Ida Monday, the day that the city gave us off for school because a lot of the city's still underwater from flooding and a little concern about wind too, but it's mostly about flooding today. We were very fortunate that the hurricane missed us, although in the background you can see where some of the early parts of the storm surge were coming in yesterday morning. I shot those videos from the lodge at Gulf State Park. But alas, y'all didn't come here to learn about hurricanes or the fact that Mr. Reeds has done homework all weekend long, hurricanes or no. He still has homework too, so don't feel bad when I ask you to do 20 minutes of homework at night. I've worked literally all weekend long. Let's get started.
Have you ever heard the weather forecaster say there's a 40% chance of rain or a 60% chance of snow? Have you ever wondered what those percentages mean? The percentages that forecasters give are a combination of their confidence of a weather event happening and how much of the area will get that precipitation. So, if your area has a 40% chance of rain today, it means that if there were 10 days where the weather conditions were exactly like it is today, it would be expected to rain 4 of those days in your area. If you have a tablet, you know that updates are a part of owning one. Many apps require regular updates to stay current and to be able to function well. The update often shows a progress bar that tells you how far you are into the update. When the bar shows 20%, it means that 1/5 or 20/100ths of the download is complete. The Food and Drug Administration requires most foods to have nutritional labels on the packaging to show serving size, calories, amount of fat, and other information. The label also shows the percent of the recommended daily value that the serving size provides. For example, the 13% daily value for saturated fat means that if you consumed 1 serving of this product, you would have met 13% of your daily goal for saturated fat. Another way to say this is that your daily goal is 20 grams of saturated fat. Consuming 1 serving of this food provides 2.5 grams of saturated fat. How can you use fractions, decimals, and percents to solve everyday problems? Are you ready? Let's begin.
And with that, we are ready to start Chapter 2, Lesson 1, Understanding Percents. The objective is students will use 10 by 10 grids and bar diagrams to model percents. We got one new vocab word coming in this lesson. It is percent, which is defined as a ratio or rate that compares a number to 100. And with that, we are ready to begin. Do you ever see information given in the form of a percent? Even though you might not know exactly what a percent is, you may have used a percent in real life, like I give 100% on the basketball court. What does that really mean? Your teacher, I guess that's me, might give a test with scores in percent, which I do. Your scores are based off of 100, so it's 100%. It may be helpful to see a percent represented visually in order to solve a problem, and that's part of what we're going to be doing today. Now, on this subject, if your coach ever tells you they want 110%, I double dog dare you to tell your coach that that is mathematically impossible. You cannot give more than 100%. 100% is the total maximum. 110%, yeah, you're dead if you do that, okay? It can't happen. You cannot give more than everything. So, just double dog dare you to tell your coach that when they say they want 110%. Now, we're going to start off by using 10 by 10 grids to model percents, and as we said, a percent is a ratio or rate that compares some number to 100. Percent means per 100 and is represented with the symbol of the percent sign that you see right there. Let's go ahead and highlight that. For example, 50% means 50 per 100. And it is read as, of course, 50%. You can write it as ratios, 50:100, 50 to 100, or 50 over 100. A 10 by 10 grid can be used to model a percent. Because there's 100 squares, each square is going to represent 1%. And now we're going to flip each card to view the example of the percent and its model. And I do apologize if there's a little background noise in this one. It is laundry day. So, 45% means 45 per 100. You could write that using the colon, using the word to, or as a fraction. And it would be read as, of course, 45%. Now, if we were to model it, you would see that out of 100 squares on this diagram, you have 45 of them colored in. That means that, once again, 45% of the diagram is shaded. It is a visual representation of what 45% looks like. Now, there are other ways that you could model 45%, but it really doesn't make much sense. I mean, the first one on the left, yeah, okay, so we turned our chart sideways. That one's okay, I can live with that. But while the next two, the middle one and the one on the right, while technically they do show 45%, is it easy to visually handle that with your mind? I don't think so. So our talk about says what percent of the grid is not shaded. And the answer is, if 45% is shaded, how much is not shaded? That's right, 55%. And you can easily count that up. 10, 20, 30, 40, whoops, didn't mean to do that. 50, 1, 2, 3, 4, 5. 55% is not shaded. Now your textbook wants you to calculate what percent of this diagram is going to be shaded. How many total squares are on the grid? How many of those grids are shaded? It is, of course, a 10 by 10 grid. So you are going to pause your recording, calculate your answer, and submit it to be checked. Work all the way through all three slides if you are available to do it online. The first part wants to know how many squares are shaded. Well, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares in a row. 1, 2, 3, 4, 5 rows. 5 times 10 is, of course, going to be 50. We're going to check that, and then we're going to move on to our next slide. Write a ratio that compares the number of shaded squares to the total number. So that would be 50 colon 100. 50 to 100, or as a fraction, you would end up writing that as 50 over 100. We're going to check that work, and it checks as well. And finally, what percent of the grid is therefore going to be shaded? The answer is going to be 50%. Wow, we would really like 50, don't we, in that one? So how can you quickly determine the number of shaded squares in a grid without even counting? That's pretty tough. You got to count something, I guess. I guess they're saying instead of counting each individual square, you could do what I did, where I knew that I had a 10 by 10, so I had 10 squares in a row and 5 rows. So instead of counting, I used multiplication to solve that problem. Now it's going to be your turn to solve a problem. Figure out what percent of this 10 by 10 grid is shaded, and then plug it in, check your answer. If you need help, there's a need help section. It says, remember, there are 100 grids in the square. Count the number of shaded grids to determine the percent shaded. Pause your recording while you do this. Now, when I worked this one, what I saw was a rectangle. It's also a square, I think, but I saw a rectangle. And I know that the area of this rectangle is going to be base times height. So what I'm going to do is I'm going to count my base, 1, 2, 3, 4, 5. I'm going to count my height, 1, 2, 3, 4, 5. And 5 times 5 is going to give me 25 out of the 100 total grids in there, Check my answer. My answer is correct. So now we get to move on to the next slide. In a recent survey, 17% of people, hold on, screamer needs attention. Ouch! Get your claw out of me. 17% of people surveyed said that they have a magazine subscription. Use a 10 by 10 model or grid to model 17%. So, how are we going to do that? We're going to start off by figuring out that there are how many squares on a 10 by 10 grid. We've talked about this. That is, of course, going to be 100. And how many of those squares on that grid are going to be shaded. 17% means that 17 of these 100 squares are going to be shaded. So we're going to check our answer. That checks. Now we need to take and model the grid shaded. So we're going to take and let's see if we can figure out how to work this. So we're going to how are we going to do this? Hold on. Alright, I figured it out. We have to select the button up here, and then we're going to count up. That's going to be 10 right there, 11, 12, 13, 14, 15, 16, 17. And we can also select a high contrast button if we want. It's kind of ugly, but I don't like that. So we're going to just leave it as straight blue. We're going to check our answer, and once again, we have done well. When modeling a percent on a 10 by 10 grid, is there a specific order in which you must shade the squares? The answer? Think back to the one we did before? No, not really. There's orders that make more sense than others, but no set order it has to be. For example, if we went back to the problem we just worked before, I've selected 17 random squares, I checked it, and it still shows 17%. Now, it's not a very good visual representation because it doesn't really, it's not easy for us to count up and see, but it still shows 17%. Now it's your turn. Pause the recording and solve this problem. Check your work. When I did mine, I decided to put my 8% down the side on the right instead of doing the left or the top like we've done before. I'm going to check my answer and I still have 8%. It doesn't really matter where you do your 8 dots, you're going to get the same answer. We're going to stop this recording. It'll be the end of part 1 and we're going to start with part 2 in just a moment.